Not so fast. These videos are free to watch, so help me out by liking and subscribing. When learning to add and subtract numbers in scientific notation, a lot is made of how easy or hard it might be. In my case, I've boiled it down to 4 steps that if you follow every time, you will always get the correct answer. So let's check out these first 4 steps, only 4 steps. So first, the key component here is get matching powers of 10. Sometimes you're going to get lucky and have matching powers of 10. In fact, I should probably have example 0 here, because if I show you the simplest one, you might love it. Let's make up a problem 3 times 10 to the 7th power, and we're going to add 2 times 10 to the 7th power to it, right? Get matching powers of 10. Look at this. We already have 10 to the 7th and 10 to the 7th. So we already have matching powers of 10. So step number 2, add or subtract the first numbers. 3 plus 2. That's easy. Step number 3, keep the powers of 10 the same. Times 10 to the 7th. Step number 4, check to be sure your answer is still in scientific notation. This is between 1 and 10, so it's still in scientific notation. So we're done, right? That's the essence of this video and the techniques that we're going to use. You get matching powers of 10, you add or subtract your first values, and for the most part, you're done. You might need to do a little checking just to make sure, but you're pretty much done. So let's check this out on the 2 examples I originally planned on. A little bit more involved, but you're going to find that they work the same. And I'm going to do them in phases. So I'm going to do step 1 on the left and right first, then I'll go back and do step 2 and step 3, and then check for step 4. So here we go. Get matching powers of 10. You'll notice in the first example, I have a 10 to the 4th and a 10 to the 3rd, clearly not matching. So I'm going to multiply the 10 to the 3rd by a 10 to get 10 to the 4th. But I can't just make this second number 10 times bigger than it used to be. So I'm going to balance it out by multiplying the first one by 1/10. 4 times 1/10 would be 0.4, right? So now we've gone ahead and modified our problem so that we have matching powers of 10. Let's do the same thing on the right-hand side. We do not have matching powers of 10, right? These are like worst case scenario. Okay, so we want to find the greatest exponent and make that match up. So over here, I'm going to multiply by 10 and by 10 again. That's going to take my -4 up to -3 and then up to -2, and that's going to match. So that's our plan. But if I do that, I have to multiply this by 1/10 and 1/10 as well to get it to balance out. That's going to be 2 decimal place movements. So that's going to be, let's see, 0.31 and then 0.031 times 10 to the -2nd. So we've just accomplished step number 1 in both problems. Pretty quick. Everything else is pretty easy. Step number 2, add or subtract your first numbers. Now what I mean by your first numbers is your 9 and your 0.4, and in this problem we're adding. So 9 plus 0.4 is 9.4. That was easy. And the second problem, our first numbers are these 2 numbers, 5 take away 0.031. Now I need to do some borrowing here, so it's not going to get into some old school math. This is 9, and this is a 10. So 9 and 6 and 9 and 4. But that's not hard, right? So that's done. Step number 3, keep the powers of 10 the same. Powers of 10 on the left example are 10 to the 4th. Powers of 10 on the right example are 10 to the -2nd. And now all that's left is check to be sure your answer is in scientific notation. My first number is between 1 and 10, so that's perfect. In my second problem, it is also between 1 and 10, so that's perfect. Done and done. That's all there is to adding and subtracting numbers in scientific notation.